So I'm going to try and run through the slides fairly quickly, leaving us about 10 minutes for a Q&A session at the end. So yeah, we'll give it a shot. This is the same presentation I gave the SEC a month ago, and very similar to my last presentation here, with a few updates. And I really appreciate Bruce King's presentation. There's a number of considerations that tie into what he was speaking of. In this picture of wheat, for instance, a gentleman I know is making wheat plywood, but the lobby from the APA has prevented that product from entering the market. So a lot of those institutionalized building products definitely need to be changed and assessed. The quotes here, one is actually a friend of mine in Richmond who runs an organic seedling company, says plants and animals are systems that run on sunshine, dirt, and rain. Humans are an overlay network built on these systems. Very tech-minded perspective. And I think it level sets people's position within the larger Earth systems. So we'll mostly be talking about sunshine, dirt, and rain. If you can keep that in mind, give some context for controlled environment agriculture. How do I change? Okay, thanks. So two concepts are afforestation and urban sprawl. Picture on the left shows a poor agricultural practice where forested hillside has been denuded. Picture on the right raises the question of what is a greenhouse? Is a greenhouse exempt from permitting? Or is a greenhouse a F1 factory zoning? And there's very little code at the county, almost zero code for cities, and the state, I think, has about 1 page of code for what is a greenhouse. So
where is that?
That's Almeria in Spain. This area is a desert that was used only for filming spaghetti westerns until a group of people brought in some dirt, put up some plastic, and began growing vegetables that now supply a large amount of the fresh vegetables for Europe. They have a desalination plant. They bring in dirt. They covered it with plastic, and the surface temperature of this area is 4 degrees Celsius lower than it was before they covered it with plastic. So this is one example of a sort of radical reimagining of environment and structure. It actually reminds me of the new design for the Google campus that Bjarke Ingels came up with, where you have a large glass curtain and buildings no longer have shape; they just exist in space underneath a curtain. So maybe he got the idea here. And before I go any further, I wanted to also thank Amory for introducing controlled environment agriculture. I didn't expect to see bananas growing in his house in Colorado, but it's helpful to ask the question, does anybody know where the bananas consumed in Europe are grown?
Africa? South America? Then like Costa Rica? Ecuador?
Some in Central America for sure, but Iceland. The geothermal energy is used to grow bananas in greenhouses in Iceland. So the idea of where sunlight comes from, where the dirt comes from, where the rain comes from is up for grabs in a very big way with the way we've conceived of agriculture. So there's 2 main categories of structure that I work on. One's greenhouses and the other is indoor growing or growth chambers. The difference being greenhouses have natural light and indoor growing does not. This picture shows an example of this light fixture here. It's a liquid cooled LED. The heat's recovered from the lights and then can be used for heating of the benchtop system to keep the plants warm at night or wintertime. Things like light deprivation, other lighting strategies, and potentially a lit up greenhouse. The state of California put the limit at 25 watts per square foot. I just did a quick calculation. If that's actually used, that's 15 times greater than the zero energy code for a building. So it's a very high energy use, even when it's in a greenhouse, and double that when it's indoor growing, roughly. So for the other type of structure is growth chambers and growth rooms. A couple examples are basil and lettuce and tomatoes, and cannabis, another example. A lot of the work in the space tracks CO2 temperature and relative humidity. And there's research that's enabled into light, soil, and rain, so to speak, by a controlled environment. At UC Davis, for instance, they don't do a lot of research in the greenhouses. They have 250 growth chambers because the greenhouses are just too variable. So understanding the plant stress or optimal plant environment or optimal nutrients, those are subtle variables which aren't well understood out in field crops generally, can't even be experimented on in greenhouses that are inside a growth chamber. So the Department of Energy put out a few energy use slides or graphs, and they estimate that only 1% of the horticultural lighting is used in vertical farms, 89% is used in single stack or single layer indoor growing, and 10% in supplemental light greenhouses. So the greatest savings are up in the indoor growing areas as it relates to the amount of energy being used. So that's an area of focus. And this slide's meant to show that we can increase the intensity of growing, and there's a relationship between productivity per square foot versus extensive agriculture, which covers a very, very large area of land, and worth considering how much land is used for agriculture versus forests or housing or other human uses. So what we've done with the liquid cooled LED light is set up a system that can reduce energy use in the controlled environment space. So you saw 41% energy reduction potential, and that really is just the LED diodes. Because the LED diodes are kept cool, there's an additional 20% of efficiency for the diodes themselves. But with the heat recovery, we're able to address the other 50% of energy usage, which is really the HVAC and other cooling loads that are associated with controlled environment growing. So we're expecting up to a 75% reduction in energy use by using liquid cooled LED. The relationship with farmers and engineers is being facilitated by PG&E and other investor-owned utilities through both incentives and financing. So the on-bill financing program for agricultural projects is applied to a range of systems that are reviewed by the Investor Confidence Project, and then may be granted 0% financing for the energy efficiency project. So we're working very closely with PG&E to explore a variety of solutions for large projects.
Nick, can I ask, Pierre showed us that 25% of the greenhouse gas emissions / energy is roughly from buildings. Do these buildings count as those buildings, or is this in the ag section? And the second part is, what is approximately the percentage of California's GHGs coming from ag like this?
Ag like
Indoor ag.
From indirect. So
of all the strawberries, blueberries, marijuana, whatever it is, just in terms of indoor ag, greenhouse gas pollution.
I think it's on the order of magnitude of 5 to 10%. I don't think we have great data on that.
Put it, it's like roughly the equivalent of all of our residences. Because that's at 9%, 7%.
I think the question I would ask is, what is the percentage of indoor ag versus total ag?
Well, I'm just asking about the percentage of pollution.
Yeah.
But continue. I don't want to take too long.
Yeah, I think I was answering the wrong percentage number there for you. So I take that back. The estimated energy usage has been written up by the Department of Energy in a pretty recent paper, so I'd refer you to that. It came out in December. That's what a lot of those previous graphs are from. So they've got the best current estimate on the amount of energy use from lighting, horticultural lighting. I think that's your question.
Continue on.
To a degree. Okay. So, then maybe more at the heart of your question is the question of fresh produce. And the idea there is that in Western countries, people are happy to pay more for fresh produce. They sometimes call it local produce, but it sort of means fresh produce. And that is a driver for controlled environment agriculture, because the cost of rapid long distance transportation is too high for a lot of the perishable produce. So these are non-essential, nice to have, not must have, quality, fresh produce that people would like to buy, and at an increasing rate globally. So the concept of controlled environment agriculture isn't understood in terms of feeding the world. It's understood in terms of supplying fresh produce to developed countries, I think is the part of the answer to what you're getting at. So the image on the left shows a number of plant stresses, sort of agronomist level considerations. And the picture on the right shows part of what agricultural engineers are looking at, which is now a local area network that is connected. The devices are connected. The monitoring is all connected to an Ethernet network, and that includes everything from heaters, ventilation systems, CO2 irrigation systems, fans, environmental sensors, there's a fogging system, and the lighting system. What the Agnetics light does is utilizes the position of the light to provide a deployed gigabit Ethernet open platform, so that all of the environmental sensors can be plugged directly in, and the data can be collected for a large area inside a greenhouse. This can include camera data, things that are very much available through camera remote sensing, both from satellite and plane and drone, but aren't traditionally seen inside a greenhouse or inside a room, inside a growth room. So in addition to energy reduction, we're attempting to address the idea of monitoring so that the systems can be verified over time. Any incentive or financing that's received comes with a 5-year monitoring obligation. We're being asked to continuously monitor the energy consumption, the rate of flow of water through the lights, and the temperature, and temperature out to verify the BTUs that are actually being recovered for the system. So that level of monitoring is really exciting for us. We're really happy to be able to have the opportunity to validate the system over time. And we think that we'll, through integrated hydronics, be able to demonstrate a number of other energy efficiency technologies that get associated with hydronics approach that can be very analogous to other building types, not just controlled environment agriculture. If you, for instance, remember last year there was a slide about the lighting load and the water heating load, and they were sort of equal in the pie chart. So in this case, recovering heat off of a light may solve two issues with one source of energy. So
5 minutes, just saying.
5 minutes left. Okay. So our energy and time-dependent valuation considerations are shown here. And the options for thermal storage, the options for hydronic thermal storage, ground source heat exchange, options for solar thermal and solar PV integration are all major considerations in controlled environment agriculture. And district heating through thermal storage becomes another exciting consideration as we implement more hydronic systems. There's increasing levels of complexity that can be brought to bear. And looking at these integrated systems, we're very happy that we don't need to model them, that we can do 5 years of monitoring to show how they're working, because one would not be able to model such a system.
Yeah.
We're doing worm farms for wastewater usage, no longer trucking winery water from Napa to Oakland, now putting it into worm farms. Another part of controlled environment agriculture. Biogas and the waste product from agriculture is a hot topic, as it is here in Humboldt County. And carbon capture and storage, sort of the number one issue here, really. There's a lot of carbon enrichment going on, and there needs to be a government mandate, no more fossil CO2. It needs to be captured CO2 injection into these facilities for sure. And beyond that, there is a company I'm working with that's doing field enrichment, where they're in an open field, an uncovered open field, enriching winery, grapes, and other crops by general CO2 direct dispersion into field.
Gasoline,
CO2?
essentially? Is that fossil fuel being broken off?
It's CO2 from a bottle, so we don't necessarily know how the CO2 got in the bottle. It could be from, it's probably not from a captured source. It's probably just mined out of the ground, because CO2 is so ubiquitous under the earth.
So it's not broken off of hydrocarbons. You're just saying pull CO2 out of the ground.
That's where most of it comes from. Yes. Yeah, we're not capturing much of our CO2, and if we did, it could only be used to satisfy a very limited amount of the available CO2.
In fact, when you say fossil, you mean it's just old CO2. You're not saying fossil fuel CO2.
What I'm saying is fossil fuel-based CO2, CO2 from combustion. If we can, instead of using, so yeah, fossil CO2. So what I mean is CO2 that exists underground that's being brought up. So the CO2 pockets that are mined, they're brought up, would be called fossil CO2. And that might not be the right term for it, but I wanted to differentiate between captured CO2 and fossil CO2. I think I heard fossil methane for the first time. Here, stop using fossil methane was Mark Fisher's statement, I believe. And so stop using fossil CO2, meaning stop mining CO2. There's plenty that we're making that we can capture. In fact, there's so much, it essentially has to be a government mandate to get that to happen. Oh, great. And carbon neutral robot farms, the idea being that a lot of the robot farming that's happening with converted tractors really could be electric vehicles, that having combustion on the farm is not necessary. And the last, and probably the biggest point I'd like to bring up is the idea of carbon labeling. Folks are willing to spend a lot more on their produce and fresh vegetables and fresh herbs if they believe it's produced locally, or if they even believe it's environmentally friendly. Therefore, figuring out a system where people can vote with their pocketbooks at the point of sale is potentially one of the quickest and largest societal pressures we can put on manufacturers and industry to go ahead and make these changes. So when I started learning about Passive House 15 years ago, almost, I said to the Passive House community, well, what are you doing for code change? How are you going to implement this? How are you going to implement this on a broad base so everybody's forced to do it? And they said, no, that's not what we do. People do Passive House because they want to. And it took me a while to even come to grips with that. And I still struggle to sort of accept that position, but I think it's particularly true in carbon labeling and carbon considerations that there needs to be a way that the people who want to do the right thing can make the decision for themselves to do it, and becomes at that point a moral question, and the religion of carbon efficiency or energy efficiency becomes something that can be effectively practiced. So hopefully that's an opportunity in the near future for better carbon labeling of products. It's starting to happen in produce, but we don't see it a lot. I'm really excited to see it more in building materials. And that's all. Any questions? Yay!